Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue our problems on continuity equation. In that problem 4, this question has appeared in GATE 2015. The question reads as follows. A fluid enters a control volume through an inlet port denoted by subscript I and leaves two outlet ports denoted by subscript O1 and O2 as shown in the figure. The velocities may be assumed to be uniform across the ports. The rate of change of mass in the control volume in kg per second at any instant is dash. Now here this is a question which is actually very easy, but while calculating the student has to make sure that he or she doesn't make any mistake in the calculations. Okay, so the thing is simple. The mass flow rate, this is the integral form of continuity equation. So this can be said like this, that is d of dt of m is sigma of I is equal to 1 to n rho v cos theta a of that ith inlet or outlet is equal to 0. Now once we get this, how to solve this? Let us see. Here what happens is this is mass flow rate. So mass flow rate, that is m dot, I will say, this is equal to summation of all these things. Now whatever is coming in, we will take it as positive, and what is going out, we will take it as negative. In that sense, I can say this as sigma m I is equal to 1 to n rho v cos theta into a of I. Now let us do that. So m dot would be here, first one we will take, which is equal to 5.5 into 3 into 3 is the one cos 40 degrees, which is given here, cos 40 degree into 0.2, because 0.2 is the area. So this is the first inlet. First outlet, if I see, I have to do minus. So the first outlet 1 would be 5 into 2 into cos 30 into, if I see the outlet here, the area is 0.15, correct? 0.15 minus the second outlet, if I see, it is 5 into 1 into cos 20 into 0.1. Now here writing this, we have to be very careful. There are a lot of times we do mistakes in writing these things. Okay, so it is always better we take one by one, because if we do a calculation mistake, it's easy for us to test. Okay, although if you don't do mistake at one time, you will save time. Okay, so 5279. If you are prone to mistakes, then this is the way you may have to do. 4698 minus 1.299. So the answer what comes is 0.7591 kg per second. So answer is 0.7591. I hope you have understood this, students. Thank you very much.